What does an action-adventure game like Marvel Spider-Man, an open-world driving sandbox like Grand Theft Auto, and an open-world RPG like Assassin's Creed all have in common? Cold-blooded murder? Well, yeah, actually I suppose they do. Say what you want, Spidey, but there's no way that guy would survive that fall. What I'm actually talking about, though, is artificial intelligence, or more specifically, traffic-based AI. Now, it's worth mentioning that many of these games have incredibly complex systems for handling AI that would be way too difficult and complicated to cover in a single YouTube video. However, you might be surprised just how easy it is to make some believable traffic AI with just a few lines of code and some elbow grease. Not literally, just, there's going to be a lot of clicking involved. If the environment affords it and would commonly accommodate other people, such as a town, city, or maybe even a Paris fashion show, adding a level of perceived autonomy and guided movement to your NPCs can act as a really nice backdrop and really help bring your project to life. So let's just think of today's episode as an exercise in virtual set dressing. Hi there, I'm Matt and welcome to Game Dev Guide. In this video, we're going to take a look at how to use a simple waypoint system to build a basic AI behaviour for pedestrians and traffic. We're going to look at how to build and draw a waypoint system complete with easy visualization and manipulation in the scene view. We're also going to look at how to use these waypoints to move our NPC characters and also build support for these waypoints to be branched to allow for more natural movements. So with that in mind, let's get started. Allow me to introduce you to Eric. Eric likes going for walks, so we want to give Eric some places to walk. I've set him up with a super simple character controller. As you can see in the script here, we can set a destination for Eric to walk to, and he'll animate his little pale self over to wherever we tell him to go. When he gets within a set distance of his destination, he'll flag the destination as reached. We're going to start by building a super basic connect the dots style waypoint system that Eric can walk between. But this is me, so rather than just making a bunch of game objects manually, we're obviously going to build a tool that lets us place, edit, and visualize waypoints. Let's create two new scripts, one called waypoint, and the other we'll call waypoint manager window and place it inside of an editor folder. In our waypoint script, let's create two references to a waypoint. One will be the previous waypoint, and the other will be the next waypoint. We'll also create a float called width, which will cap at a range of 0 and 5 for now. Let's also add a method called getPosition. This will return a random point based on the waypoint width, and basically will give some degree of freedom for our characters to move between when they're moving towards a waypoint. In our waypoint manager window script, we'll create a quick static method to open the window. We're then going to build a simple window that allows us to easily manage our waypoint system. Let's create a public transform called waypoint route. This will be an object we assign that we'll use as the parent for our waypoints. And on GUI, let's create a serialized object for the window so we can easily draw its properties. Then let's create a property field for our waypoint route and make sure to apply the modified properties. And let's add a message to make sure it's assigned. If it isn't, we'll create a help box message. If it is, we'll create a method called drawButtons, which will enclose in a vertical layout. And here we'll create a button and a method for adding a waypoint. In here we'll create a new game object and generate a name for it based on the child count of our waypoint route. We'll also assign the waypoint component. Then let's set this new waypoint as a child of our waypoint route. And we want to make our waypoint system automatically link waypoints when we create a new one, so let's get a reference to the waypoint component, and if the route transform has more than one child, we'll assign the previous waypoint like so. Just for some nice quality of life features, we'll also set our new waypoint facing the same direction as the previous one. And finally, we'll select the new waypoint as we probably want to edit it. Now, if we go back into Unity and open our window, let's create a new game object here, which we'll call waypoints. Then let's assign this into our window. And now each time I click this button, we get a new child added to our waypoint group, and each child has our waypoint component attached. So this is a good start. We've got a tool that will easily allow us to spawn new waypoints. The next thing we need is some easy way of seeing how each of our waypoints are connected. Something ideally that will help us tell which waypoint is attached to which, and the relationship between them. It would also be good if we could easily just select the waypoint here in our scene view, rather than having to find a specific waypoint in the hierarchy. So let's create an editor script that uses some gizmos to help us achieve this. In our editor folder, let's create a new script called waypoint editor. At the top here, we'll create an initialize onLoad attribute. Then let's add a new static method called onDrawSceneGizmo, which will take in a waypoint and a gizmo type as parameters. We'll then add the drawGizmo attribute, and we'll add gizmotype.nonSelected, gizmotype selected, and gizmotype pickable. This way, we're telling Unity to draw the gizmo regardless of whether or not the game object is selected. And by declaring this as pickable, we're also telling Unity to make the gizmo selectable. At the start here, let's set the color of our gizmo depending on if the game object is selected or not. So if it is selected, it'll be a solid yellow color, and if it's deselected, it'll be slightly transparent. Then we'll draw a sphere in the center point of our transform. Next, we want to draw a line the width of our current waypoint's walkable area. And now let's draw a line from our current waypoint to both the previous waypoint and the next waypoint. Now, if we take a look back in Unity, we should be able to see that our waypoints are now visualized in the scene view. So this is pretty good. However, if I want to add a waypoint between two existing waypoints, it's a little awkward. So let's fix that by adding a couple of contextual buttons to our editor. Back in our waypoint manager window, let's get a reference to the currently selected game object and check if there's a waypoint attached. If there is, let's create 3 new buttons and methods. Our first button we'll label as create waypoint before, our second create waypoint after, and our third remove waypoint. Then let's make a method for all 3 of these and assign them to our buttons. In our create waypoint method, let's create a new waypoint and get a reference to it. Then let's also get a reference to our selected waypoint, and we'll position our new waypoint with our selected waypoint. We'll check if the selected waypoint has a previous waypoint assigned, and if it does, we'll set that as our new waypoint's previous waypoint instead, and set our new waypoint as the next waypoint. Finally, let's set the sibling index of our new waypoint so it's in position nicely in the hierarchy. Our create waypoint after method is pretty much the same, except that we're swapping out the next waypoint reference instead. So let's just go ahead and do that. Finally, in our remove waypoint method, we'll swap out the reference on our currently selected waypoint to the previous and next waypoint, before destroying the selected game object. So now we've got a pretty flexible tool for editing our waypoints and a nice visualization for them. So with that, let's go through and create our little waypoint loop for Eric to walk around. We'll assign our last waypoint back to the first one to close the loop here. And now we just need to write some logic to move between the waypoints. So let's create a new script called waypoint navigator. In here, we'll get a reference to our character movement controller and a current waypoint. On a wake, we'll assign the controller. And then we'll set the destination of our controller to the position of our currently assigned waypoint. Then in our update method, we'll check if the controller has reached the destination, and if it has, assign the next waypoint and set the destination from that waypoint. So all we have to do now is assign a waypoint here, and then click play. We can see that he makes his way around the waypoints. Go Eric, go you, 10 points for basic AI, hooray. Now obviously you came here for more than a guy just following some waypoints, so how about we make a whole load of guys follow some waypoints? Let's create a new script on our waypoint route called pedestrian spawner. We'll use this to create multiple versions of Eric and assign him to a random waypoint. At the top here, we'll create a public reference to our character prefab. Then we'll set a variable to determine how many of them to spawn. And let's create a coroutine called spawn, which will iterate through our waypoints for every spawn number. We'll simply instantiate the prefab, then get a random child from our waypoint list and set that as a current waypoint for our character, and then move them to that position. So back in Unity, if we set the number to say 100 and hit play, we'll get a little bit closer to creating some actual traffic. If we fly around our little square here, we can see that we've got loads of Erics walking around in circles, hooray! One of the small touches I've added to Eric is a marginally random speed upon spawning. This makes the traffic move in a little bit less uniform way and makes it a little bit more realistic, because obviously not everyone is going to be moving at the same speed. So this is good, but it could use a bit more variation. After all, not everyone in traffic is heading in the exact same direction. So let's start by adding support for our character to walk the other way around the waypoint system here. In our waypoint navigator script, let's add a number for direction. So let's randomly generate this number when the script starts. And then down here, when our direction is 0, we'll assign the next waypoint as our current waypoint. But if the direction is set as 1, we'll assign the previous waypoint as our current waypoint. And now if we take a look, we have a much more natural flow to this sidewalk. We're making our way to a more realistic pedestrian traffic system. So it's nice that they're walking in circles, but we really want to give the impression of a level of autonomy to our little guys. The problem really lies with the way we've built our current waypoints. We want points in our system where we can give our guys a chance to break off and head down a different path, so we need to add support for branching. Let's go into our waypoint script and add a new list of waypoints called branches. In our waypoint editor, let's visualize our branch by drawing a blue line to it. And then in our editor window, let's add a button to add a branch with ease. And so creating the waypoint here is pretty much the same. Once that's done, we then assign it as a branch to our old waypoint. Next, let's head over to our waypoint script and add a new float to it called branch ratio, giving it a range of 0 to 1 with a starting value of 0.5. In the update method of our waypoint navigator script, let's check if there's a branch on our current waypoint. And if it is, let's do a random check against the branch ratio to determine whether the branch should be taken or not. So then if we're choosing to branch, let's randomly pick a branch as the next waypoint position. Now part of this will mean that we might run into some dead ends, so we'll now need to handle that too. Let's check if the next or previous waypoint is null, and if it is, we'll change direction. Now, back in Unity, we can create our branch. Let's grab the node by the crossing here and add a new branch. We'll then pop it into position and create a new waypoint and move it to the other side of the road. Then let's create another branch here and start placing some more waypoints. So if I just play this, we can see that now when our characters reach this point, sometimes they'll split off and begin on their new path. Annoyingly though, we end up in a situation here where they turn back on the crossing because they don't definitely take the branch off. And this is where the waypoint ratio comes in. At the end of each crossing, I want to guarantee that they go back onto a track. So I'll select this exit branch here and give it a ratio of 1. Now anyone reaching this node will always branch onto the sidewalk. On the other side, we'll move our entry node over and create a new exit branch node, and also set its branch ratio to 1. Now, as you can see here, we have an entry node onto our crossing from the sidewalk with a random chance of branching, and another exit node off of our crossing, which will always be branched from. Using the waypoint system on a crossing like this, with entry nodes and exit nodes, means that anyone that has branched onto our crossing will now successfully leave it. As you can see here, the branch ratio gives us more freedom over how our AI uses branches and allows us to create more advanced control over our traffic flow. So I'm really happy with this. All that's left to do really is go through and add a few more branches and continue these waypoints. Eventually, we end up with something like this. With just a little bit of work, we've got a nice and varied pedestrian traffic system. Now obviously there's a lot more we can do here. For instance, if you wanted to take it further, perhaps you could add some variation to the waypoints. Maybe have some spots where people stop and look at buildings, or perhaps adding some animations so people do different things and move in different ways. There's a lot more to explore to really flesh this out, but hopefully this is a great starting point for you. And that's pretty much it for this video, so let me know if you enjoyed it by hitting the like button below and leaving a comment. Definitely let me know, as I'd like to make another video in the future taking a look at some more complex behaviour for this traffic system by perhaps adding vehicle traffic and having the two interact so pedestrians will wait to cross the road and vice versa. There's a lot more I can do here, so I may also look at adding some more complex interactions in too. Additionally, I put quite a bit of time into building the demo scene and finding the best way to present all this information, including spending quite a bit of time messing around with the post-processing stack to achieve this tilt-shift miniatures effect, so I'm definitely likely to explore how to do that in a future video. If either of those are something you're interested in seeing, then be sure to subscribe to the channel, because you'll be among one of the first to see a new video whenever it goes live. Additionally, if you want to see more videos like this, then feel free to check out some of these other videos already on the channel. Otherwise, as always, thank you very much for watching, and I will see you again next time.